My name is Eric.
And my name is Ilaya.
And what are we going to talk about today, Ilaya?
Let's get started with Spring Cloud Stream. First, I hope most of you would have attended talks from Mark and Marius on Spring Cloud Stream and Spring Cloud Dataflow. Just a reminder, I just wanted to give a glimpse of what the Spring Cloud Stream apps and
how many of you know about Spring Cloud Stream? Well, quite a few. That's good.
That's good. So, yeah, it's a simple example. I just wanted to show you.
Yeah.
Oh, the font size.
So what are we going to do here?
I'm trying to run a TikTok example where the time app emits timestamp events, and there's a log app that just show it in the console.
Okay.
And there is a messaging middleware inside. Since this Spring Cloud Stream app, those apps are bound to a messaging middleware. All we need to set is a specific destination name that is same for both the apps. Let me increase the font a bit.
Sure, go ahead. Just go ahead. I'm going to do it later.
Okay. So as you can notice, the destination name is common for both the apps here, and the time app emits events to the Rabbit messaging layer here. There is a problem here. The server port. Maybe I can use a different port.
Yeah,
I'll choose a random.
Yeah, someone is on 8080.
Then I'm starting the log app here that uses a random port, and it connects to the same destination where the time app sends the messages into. So as you can see, the log app receives the events from the time app. So here, both these apps, they don't know each other, but they connect to the messaging middleware to the specific destination name that we set. This is a simple Spring Cloud Stream app that lets you perform, have a microservices app deployed, and they connect to each other using a messaging middleware.
Okay, this is pretty cool. But I'm more into video games myself.
Oh, I know that.
Yeah, and I wrote this Minecraft mod thing that I'm going to show you, and also a little Spring Boot app. So just so you know, this is a no Pokemon session. So we're not going to talk about Pokemon today, just Minecraft. They can all burn in hell. So yeah, I wrote this little Minecraft mod. It's pretty easy to write one. And I thought I could have a native server that would emit events as animals and sheep.
So you need to get the events from that TCP server in there?
Yeah, so simple server that emits JSON events. Okay. And I also have that simple Spring Boot app that draws plots on the screen using a swing. And I'm wondering if we can hook them up together.
Yeah, right? I think we need an app that receives the events from the TCP server here, and then all we need is to connect both the apps together.
Oh, okay, so I'm going to write an app that reads from the TCP server, and we can hook it up to the map app. Okay.
Yeah, wait a minute. I think...
What?
No, we need to check whether we have an out-of-the-box app from Spring Cloud Stream app. So Spring Cloud Stream app provides out-of-the-box apps that you can use. If all you can do is to configure those apps and then deploy them. Or you can also extend those apps. There are Spring Cloud Stream app starters that you can extend, build something on top of it. But if you have some custom application that you can build from scratch, you can do that.
Okay, so I went there. It's called the Spring Cloud Stream App Starters.
Yeah, we would like to see whether we can have the TCP client app in there. Yeah, you can see the TCP client as a source.
Oh, TCP
so that's
client.
all
that
we need.
Looks good.
Yeah.
Okay, so I'm going to use that.
Yeah.
Okay. I'm a bit French today. So what do I need to do? Then I'll download the app. Okay, so I'm going to the Spring repo, right? So
no, actually, you know what? We have Spring Cloud Dataflow that lets you orchestrate these apps. You don't have to have a Spring Cloud Stream app like what we had, like timestamp, time log. You can have Spring Cloud Dataflow that can orchestrate these apps together. And,
okay.
So Spring Cloud Dataflow also has this deployer concept where you can hook in a specific deployer implementation. So you can deploy these apps into local for your testing and debugging purposes, and then you can deploy into Cloud Foundry, Mesos, or Kubernetes.
Okay, so let me see if I got this right. So we have this Netty server on the one side. It's embedded into the Minecraft game.
Yeah.
And I have that app that we want to connect to it. And basically what we're going to do is we're going to use an out-of-the-box already provided by Spring Cloud Stream app. That's called TCP client.
Yeah.
It's going to connect to the Netty server. And then it's going to pipe the events to the other app. Is that it?
Right.
Okay. So this one on the left is going to be the source.
Yeah. So that's the out-of-the-box Spring Cloud Stream app.
Okay. And
that
the map
knows how to bind to the messaging middleware.
Okay. And we're going to turn the map app into a sink then.
Exactly. Yeah.
Okay. So before we do that, maybe I need to show you how this Minecraft thing works. Any Minecraft players in the room? Wow, quite a few. So we're going to have fun. So this is Minecraft. You may have heard of it. Simple game. I'm walking around. There are some sheep there. And I wrote that little mod. You can actually configure it. Here it is, TCP events mod. And what it does is that it opened a port on 8080 port. And every time a sheep or the player moves, it just broadcasts some JSON event. As a matter of fact, we can see that if I use, for example, Netcat here, and I move around, then you can see every time a sheep moves, I get the XYZ coordinates, its offset, and its color, some stuff like that. You could even try it yourself if you're on the same network as us. Let me see. This is unscripted, right? We're dangerous territory here. So if you guys want to go and netcat on this IP, you may be able to see the same events as I do, so port 8080. Okay, so this is the events we want to capture, and how am I going to do that? I have this...
So do you have Spring Cloud Dataflow installed?
Yes, I downloaded that, so it comes as a server, right?
Yeah.
I use the local server. Is that what I need to use?
Yeah, just for testing and debugging. That sounds good.
Okay, what else is available?
Do you have a shell?
Yes, I run the shell here.
And do you have the apps in there? Remember, Spring Cloud Dataflow doesn't come up with these apps out of the box, but you need to tell what apps you need. But we have a way to register these apps, register these out-of-the-box apps.
Maybe I asked earlier. Okay, I think I get it now.
So you can go to the Spring Cloud Stream, all the list of out-of-the-box apps in there. So you can just import that file here.
That thing. Oh, so we're using okay.
Yes,
we're using RabbitMQ.
Yeah.
So I'm gonna.
If you use you can import all those apps that uses Kafka binder in there. In this context, we are using RabbitMQ, so we are using the apps that have RabbitMQ binder in there.
So what's behind that URL? Okay.
You can see the list of apps.
So I need to do to go to the shell and do app. Sure, yeah. App list. Here they are. Okay, that sounds pretty good.
Yeah, see there is a and then the type of the app, which is source, and then TCP client. So that will list all the properties and some other information about the app.
Okay, so these are boot properties, right? Like configuration properties?
Yeah, yeah.
Okay.
Like everything is built on top of Spring.
Port?
Yeah, that's the port
so
that we need to use to connect to.
Yeah. Okay.
That's a TCP server port.
Okay. Obviously, I can change the host. I'm going to use localhost and a bunch of stuff as well. Right here, it's it's almost done. Can everyone see? It's already there. I mean, I know I'm close to it, right?
Yeah, you're close to it. We just need to make sure this app is Spring Cloud Stream app now. We need to bind this app into a channel that we are going to use here. So enable binding, and then it's going to accept that interface, which is sync. As you can see, it has an input channel, and there is a name of the channel that we use to configure.
Okay, and you said, there is source as well. Okay, so source is the exact opposite in a way, right?
Yeah.
It's as an
output. That's like our TCP client.
Okay, and processor, what is it?
Channel. to your service activated method. Like your message handler needs to be done. So here, enable this as a service activator. Say this.
So it's a Spring integration annotation.
Yes.
This okay? Is that all I need to do?
Yeah. So now, since we have a.
Actually, I haven't. I cheated. So I guess I need to build the app.
Now, yeah, you need to install this app so that it's in your Maven repository.
Okay. I'm just going to build it.
Okay.
Okay, there it is. Then what do I need to do? I need to import it as we did.
Of the app.
So the name of the app. So
yeah.
What is this? Do I choose that? Map
yeah,
sync.
just.
And I think the version is.
And the version, yeah.
This. Okay.
And you're good to go. Make sure this is registered. And
okay.
Can we list the apps just to see if this is available in our registry?
Map. Okay.
Okay. So we are good to create the stream now. Remember, the destination name is nothing but the physical destination in the messaging middleware. Here, Spring Cloud Dataflow does it automatically when we create the stream.
Okay, but I could still do it, run it like java-jar.
Yeah, I could, of course, yeah.
But so what Dataflow does is that it does all the plumbing for me and I guess some more.
Yeah,
okay.
And then
so let's see.
Yeah, you can orchestrate this stream.
Okay, so how do I create a stream? I've heard it's stream create, right?
Yeah.
Okay.
And then you need to have a name for the stream.
Okay, sheeps.
Okay, and then a definition of the stream, which is the DSL.
Okay.
So here our source is TCP client.
Indeed. So TCP
it
client.
Autocomplete.
Oh, yeah. That's nice.
Yeah.
Love it.
That's cool, isn't it?
And so I need to set up the port, right?
Yeah, remember we saw the port configuration property in there?
But
so
it was
the port.
It was TCP.port.
Oh,
so now I can use just port. Right?
Yeah. That's another out-of-the-box capability that we have.
Okay, we'll talk about that later, I guess. So the port is 8080.
Yeah, that's the TCP server port that we are going to connect to.
Yeah, that's running in Minecraft. And then I need to shuffle that to the map
sync, yeah.
Okay, so I'm going to do what? A pipe?
You have a pipe.
Okay.
And then sync, the name of the sync, which
so
is map.
It's map.
Yeah.
Okay.
That's all.
Okay, and then I deploy the stream, right?
Yeah, you can deploy now.
Okay.
Good to
Should
go.
I hit enter?
Yeah.
Okay, fingers crossed.
So now.
So what's happening? Oh, I see it's deploying. So it's I'm using the local server here, right? But I've heard there are other implementations. What's that?
Yeah, so we have Cloud Foundry, Mesos, and Kubernetes implementations. So depending on the implementation, you just need to have a deployer dependency in your Dataflow. The Dataflow server needs to know what deployer it is using. So in this case, it's local.
Okay, so I'm using local.
Local.
And
so
there is a yarn as well.
Yeah, of course. Yeah.
Okay, so it started, so one instance
so that
of the
your
map
sync app seems to be running as I see some swing.
Yeah, this is my app. So this black circle here is meant to be the player, and there are no sheeps yet because I guess the game is paused, right?
Yeah.
And so I see the TCP client app has been launched as well, right? And I guess it is.
Yeah, it's looking for the events from the TCP server now. Let's start.
Okay, so let's play a bit.
Yeah.
Right?
Yes, you can see this sheets are moving. So here we receive the events from the TCP server, and those events are fed into the map sync.
Okay, let's have a look at the.
See, now we have just made your app as a Spring Cloud Stream app and make it available in the Dataflow server.
Okay, that's pretty cool. Yeah, I can play all day, man. Okay.
Yeah, I think we only got.
Oh yeah, we got plenty of time. Let's play a bit. Okay, that's really nice. As you can see, the events are flowing.
Yeah.
And it updates the map. It's pretty cool. Okay.
Yeah, that's pretty cool.
That's nice. So
that's all you have for today?
Yeah, that's it. No, I was wondering if we could do some maybe some analytics on.
Oh yeah, of course. So Spring Cloud Dataflow has this analytics that lets you can perform as the stream. As the stream is ingesting the data, you can do parallel analysis. So you can have multiple streams created and tap into the main stream and do some parallel analytics in parallel. So it's not going to affect the mainstream of data. So in parallel, you're going to get all type of metrics. And, so currently we have a counter, aggregate counter, field value counter. So you can do that. But let's create an aggregate counter now.
Yeah. So it's just another stream, right?
Just another stream. Okay. So you can create a new stream.
So string create again.
Given a name.
I'm gonna see, I guess, the number of events by time. Can you do that?
Yeah.
Okay, so by time. This is going to be the name of my stream, and so definition as above.
Yeah, so since we have this notion of named destinations, so we know the destination is created in the messaging middleware. Now all we are doing here is connecting to that destination name. So in this case, it's going to be the exchange in the RabbitMQ. And in order to connect to that destination, we have this notation called name destination, which starts with colon.
Okay.
And then the name of the stream, which is
that I'm tapping into. So it's the one above.
Yeah, the name of the stream that you're tapping into, which is the sheeps. And the tap can be performed where there is a message producer. In our case, there is only one message producer, which is TCP client source. So you can tap into it. So you can say TCP client.
Okay.
So by default, you don't have to put it here. By default, it's the first source. So
okay. And then I put a pipe.
No, in this case, since it's a name destination, the syntax is to get the data from name destinations, which is greater than symbol.
Oh, okay, like a Unix thing. Yeah. I see. Okay, and I'm going to put it into
an aggregate counter in this case, because we are doing aggregate based by time.
Okay.
And give it a name.
Name, yeah, by time was cool as well, so I do that.
Yeah, I can deploy it.
I deploy it. Okay, and
you need an equal sign in there.
Okay. Nice error message.
Oh yeah. We can also do some other analytics. Let's do some field value counter in here.
So what's that?
So field value counter does the metric based on, like we know we have some data in there. Can we see the data?
Sure.
That you have as an event?
So it's that, it's just simple, x, y, z coordinates, delta. Entity is these, each sheep has that internal ID. So it's my beloved 207 is a nice sheep, but there's lots of friends.
So we can do some analytics based on the specific field. So we can choose a specific field and see how many number of events occurred for that field.
For example, we can see which sheep is moving the most.
Yeah.
Okay, let's do that.
So we can do field name. We can choose a field name entity here. So that will give us a specific sheep entity.
So I need to create yet another stream, right?
Yes. So this is how we do this parallel analytics. You're not getting into the mainstream. So mainstream is actually ingesting the data as the data pour in. But in our case, we are doing some parallel analytics. First, the aggregate counter is already deployed, and it's doing the aggregate counting. And now we are also deploying the field value counter here.
Okay, so
the same is the case. So you can create
new
definition.
And so I'm tapping again, right? So
yeah, the same name destination here.
Okay, I really start to dig it.
And then the greater than symbol.
Okay, and
field
then
value
counter, you say. Okay.
Or you can autocomplete, yeah. So we need to choose the field name here. Okay, so you can give it a name.
Okay, I'm going to put it by entity again.
Okay.
By entity, okay.
Sure, and then, give a field name. It's going to autocomplete, yeah.
So field name is the name of the field in that JSON payload.
JSON payload,
okay,
yeah.
So it's
entity. So in this case, entity, yeah.
Okay. And this is JSON, right? So, but my thing is emitting a byte array. So, do I need to do anything special?
Oh yeah. So you remember in the map sync. Can you go to the map sync?
The app, you mean?
Yeah, the map sync configuration had a byte as an input here.
Yeah.
So we are not going to receive a byte here because we want the text data.
Okay.
So we can have a custom converter built in, but in our case, we can do it in the DSL by specifying input type.
Okay.
So we expect text line instead of byte array here.
Okay. So it's going to get a string basically.
Yeah, exactly. So that the field name value would be determined.
Okay. And I deploy it.
You can deploy it now.
Okay.
How about we switch to the UI to see? Remember?
Yeah. So the UI is what? It's part of the...
Yeah, the Spring Cloud Data Flow has this Spring Cloud Data Flow UI, which lets you, do all the operations that shell, the way you interact with the shell. So it opens up all the REST endpoints and connects to that. It acts as a REST client. There is also a flow UI in there. It actually provides you a capability to create the stream. So there is a graphical tool that you can pipeline all the apps together, and
so it's this
create a
thing,
stream.
right? Yeah.
So now
running localhost. This is the Dataflow server actually, and I can
you can hit the
dashboard. Okay.
Yeah.
Okay, so I see there are the list of all the apps that are available. Okay, this is what
this is same as our app list command. So it's going to get the same REST endpoint.
Okay,
and these are the streams that we deploy.
Created. Okay, and I guess analytics is what we're looking for, right?
Yeah.
So what I'm going to do, we created a aggregate counter.
Yeah.
Oops, it's not there.
Yeah, maybe. Let's see. You play the game?
I haven't played the game yet. I love going back to the game.
So there are no events yet, right? So it should not be in metrics there.
Okay, so I'm going to play the game a bit so that some ships are moving.
Yeah.
By minute, is that it?
So you can, there are so many other options as well. You can choose.
Created.
Yeah, that's the name of the field value counter we created. And you can choose a chart. I think Bob. Yeah. Having to perform parallel analysis of your main string. So now remember we.
Okay, this is all pretty cool.
Nice.
Yeah.
Yeah.
Well, first of all, sheep can fall in love. Did you know that?
No.
So if you give them some wheat after, here you go, baby sheep, right? So knowing where you're going is even better. Okay. So here you go, gray sheep. Pretty cool. But it's a blue sheep then. And sometimes you can get purple sheep. Pretty funny. And then you can shear their wool, and then I did that on purpose. Okay. So did I grab it? So I've got some purple wool, magenta wool, orange wool, lime wool, and I was under Minecraft is all you can put wool blocks down. Right?
Yeah.
And I must Philips Hue light bulb. There is some so you pass hue, saturation, brightness, stuff like that, and then it yes. So this is to turn it off.
So is that the IP address stream binder?
So I see
stream dependency.
Stream rabbit. Is that what I want?
Yeah.
Okay.
If you're using Kafka, you can choose that here.
Okay.
So you need to choose which binder you're going to use for your
zip.
Yeah, you can import into your. Yeah, this is a typical.
Downloads, demo. Run on XML. Okay. So it's pretty empty.
Yeah, see that dependency in there?
Where is it?
Well,
okay, here it is.
Stream
okay, good. And so what am I going to do? So I guess I have a main.
Yeah, so you're going to have a configuration class where
we're going to put some
enable binding, etc.
Okay, okay. So I'm going to call it what? Bulb configuration?
Sure.
Bulb configuration. Okay. So it's a configuration class.
Yeah.
If I put that. Okay. Then we saw enable binding. I know about that now.
Cool.
So
and this is going to be a sync app.
Absolutely. Okay. What do I need? I guess
service activator method, typical Spring integration.
Okay. So I'm going to receive some stuff. Okay.
Yeah.
So change color, I guess. So I'm going to receive something. Let's make it a string this time.
Okay.
Okay. I'm going to call it payload. And this is going to be the service activator. Okay.
With the input channel defined. It's going to be the syncs input channel.
This is getting all natural. Okay. And then, so there is that API for the U-bridge. We saw that earlier. So I need a REST template, for example.
Oh, yeah.
Right? Okay, that's pretty easy. That's typical Spring Boot app, right?
Yeah, so you get that.
Okay, I'm going to initialize it here as it's thread safe. Okay. And what am I going to do? So what I receive is some JSON input, right?
Right.
There is X, Y, Z. Maybe I should show this, but there's also you know, the red, green, and blue values for the wool of the sheep. As a matter of fact, before we go any further, let me show you this. We're gonna, you know, stop those
the live events.
Live events from happening, and we're just gonna focus on the blocks that I lay down, right? So if we have a look at the netcat here, we see every time I put a block down, we have just that, right? So we have the color, we have the red, green, blue, and the coordinates.
Yeah.
Okay, simple.
So does this require RGB or?
Let me check. I think I saw brightness, hue, saturation.
Oh, so then we need some conversion.
Okay, so first of all, we're going to read the JSON.
Oh, yeah.
We're going to do some conversion. Hopefully, we'll look it up on the interwebs. And then we're going to post that to the hue thing. Okay.
So we are trying to get we are trying to form the REST endpoint that we need to interact with this bug, right?
Okay, so I'm going to use Jackson to read the JSON. As we saw, there is red, green, and blue, so I'm going to create a small class here. So I'm going to call it, let's say, input. And it has, so it's an int, red, green, blue. Do I need anything else? I guess we're good, right?
Yeah.
And so getters and setters. And we're good. So there are other properties. So what I'm going to do is that I'm going to tell Jackson that those other properties that are
like
not
X,
there,
Y, Z, and other stuff.
Yeah, we don't care about them. So I'm going to say in your unknown equals true. But given that those getters and setters have the exact same names as what's in the JSON payload, I think that's going to be good.
Yeah.
So I'm going to pass that using the object mapper. So it's a read value, right? And I can put a string payload here and saying that I want something of type input, right? So yeah, exceptions are for losers. We don't care about that. And we have the input. And then we need to convert that. We're going to see how we do that. And then do the put HTTP thing on the
hue, saturation, brightness values.
Okay, yeah. So about that conversion, here it is. Yeah, I know. So I need some state thing. I guess the same thing, right? JSON value. I'm going to create a class for that.
So you realize we are not going to make it before 30 minutes?
No, we are. Are you crazy? It's simple, is it not?
I hope so.
Yeah. Have some faith.
So we are converting those RGB values into hue, saturation, and bright.
Okay, so I'm going to look that API again. So BRI for brightness, hue, sat. Okay, and those values are between 1 byte, 2 bytes, and 1 byte. Okay, and this is what I've done here already, so that's pretty good. Private int saturation, private int brightness, getters and setters, and we're good. So I'm going to create a new instance of that. And then we do the conversion, so there's something in AWT that does that for us, and we're good. And then all I need to do is post that, or actually put that to the hub, and then it will go there, right?
Yeah, you're setting the REST endpoint here, right?
Yes, we'll also make sure that we turn the light on. So we're going to outcode that to true.
So by default, it's going to be turned on?
Yes.
Okay.
I don't want to do that with a curl. And so the REST template. REST template has that put. So we want to make sure we use the correct signature, URL.
There's a request object and then?
Request object and some URL variables. Okay, so I just have So the URL is going to be HTTP. So the IP for the hub I got from there earlier. And this is basically what it looks like, right?
Yeah, until that point.
Okay, I'm going to do that. And I'm going to put my state object there. And we're good. Did I miss something?
Yeah, that's good. There are no URI variables now.
Okay, so let's try that.
Okay.
So I need to build my app again. Let's go there. So it comes with a Maven wrapper, so that's good.
Remember, this is what we downloaded from Spring Initializer. We are working on top of it, making it as a Spring Cloud Stream app.
Okay. Build successful. And so
okay, so same is the case like what we did for MapSync. Now we need to let the data flow server know that this app is for us, and now we need to register it.
Got it. So I know that. App register. Name of the app is going to be bulb. Its type is going to be sync, and then I need to put the Maven coordinates of the app. So Maven. So the group ID. What did I use? So the group ID is com.example demo 001 snapshot. Okay. So com.example colon demo colon the version, and that's it, right?
Yeah.
Okay.
Can we see if this app is registered with applist command?
Yeah. Here it is. Well,
okay.
Okay.
Cool.
And then I can create a stream.
Yes. And give it a name.
I'm gonna. Foo is a good name. I'm gonna say HTTP client. The port is still 8080.
Do we have this existing streams running already? Or
yeah, but I can create a new stream, right?
Yeah.
Okay. And so what do I need to do?
Remember, this port is actually the server port that we are connecting to. It's not going to conflict. It's the TCP client uses this port to connect to the TCP server.
Yeah, it's several clients to the same server. Okay. Do I need to put some output type here?
Yes. Remember, we put string as the required expected payload in there. So how we did for the field value counter as the input type, here we can put output type as text line.
Okay.
So that we. Yeah. So this will make sure that it will not send byte arrays into the next.
But a string.
Yeah. Instead, it's going to be a text line string. Yeah.
Okay. And then I say bulb.
Yeah.
Okay. And I deploy it. Okay. So it's starting there. Okay. I guess it takes a bit of time to deploy.
So now it's going to this stream has the TCP client app that's going to receive the events from the Minecraft server as we play. And remember, we also disable the live events now. It's going to be block events only.
Okay, yeah.
Okay.
So let's have a look at those. They are there.
Okay.
Okay, and then if I do
again.
that. Oh, that's pretty cool. Green.
So we received the block events and we converted those RGB into hue, saturation, brightness, and that data is sent to this light bulb, and now it changed the color.
Okay, see?
Yeah, that's cool, Eric.
Less than 30 minutes.
Yeah.
So what can we do now?
So can we do some more?
Yeah, I guess so. Because, I remember that TCP client had all those interesting information about, the port, the host name, and stuff like that.
Oh, yeah.
And I wish my bulb app could have, some extra parameters.
Like, you can have configuration properties. That's what you need, right?
Yeah.
So we can have, remember we had, for every app can have configuration properties that you can configure as you deploy, as you create the stream. So we can have the same thing for the light bulb here.
I'm thinking maybe we could have an ID parameter so that we could make use of those 2 extra light bulbs I bought.
More. So it's buy one, get 2 free, or what?
Kind of, yeah.
Okay.
Okay. So how do I do that? So it's boot configuration properties, right? So I need to add I can add.
Yeah, this is the benefit of having Spring Boot here. So any Spring Boot configuration properties can get in here and then make it as a configuration property for your Spring Cloud Stream app. So we can have it now.
Okay,
so
I
you need that configuration
processor.
Sure.
As a trick, I make it optional. It's not really necessary, but then it's not in my app because it's only needed during the build.
Time. Yeah.
Okay. And what you're saying is that I just need to create
a configuration, Spring Boot configuration properties class.
Okay, so like bulb properties?
Sure.
And I say it's a configuration properties.
Yeah.
And I put some prefix there,
sure.
I guess. So like
yeah, this is all Spring Boot things. There's nothing Spring Cloud Stream yet.
So if I have some ID and I say that by default it's 1,
sure.
It's going to work, you think?
Mm-hmm.
Okay, just getters and setters. Okay. And so what you're saying is that, just if we have a look at that, if I build my app, if I build my app, why?
Is it there? There's nothing in there.
Who destroyed my app? Oh, my app is gone. Okay, previous window, I guess. If I build the app again, the boot
but did you enable that configuration property?
Not yet, but what I wanted to make sure of is to that. So let me put some stuff here. And do it again. And we're going to see that information.
Enable this configuration property in your main configuration.
Okay.
Yeah, like a tip class.
I can create an instance of that or put it there.
Yeah, you need to put in there like a bulb. So then now
so
this configuration property
field wiring is evil, but we do it that 1 that we got here. I guess we can change that dash configuration dash meta.
Yeah, I forgot.
Look it up. You forget every time, right?
Yeah.
I do too. So it's configuration properties classes. Okay, let's use that. Very long name. And then I put the name of the classes. Okay.
So this is where your custom properties or any other properties class that you really want to be listed as whitelisted here.
Okay. And what if I don't want to list all of the properties in there, but just one of them, for example?
Property name, so you can have a property name.
Okay.
As for example, server port, so you can use it here.
And what if I have several classes of configuration? I can just put them.
Yeah, like just what we saw.
Okay,
before.
that sounds good.
You remember we also had this app info command. This is going to list those whitelisted properties in there in Dataflow.
Okay, so we'll have a look at that. So I rebuild the app, and now if I go back to the shell, what you're saying is that I can do app info on sync colon bulb, and I'm going to see it.
The
bulb.id, the ID of the light bulb to interact with.
Yeah, this is the configuration property that we just added, which is cool.
Okay, so that means that I can use it, right? So I can do stream create bar. Definition is TCP client AT80 pipe or output type if I want here. Text plain, and I can say bulb, and I can do ID. So I get completion here, and I can do ID equals 2, for example.
Sure.
And if I deploy it, okay, where is it? So that means that now, so the other stream is still running, right?
Yes.
But if I do this, then I light
this is the
bulb number 2 as
ID
well.
Number 2?
Yes.
Yeah.
Okay, so obviously they both
are getting the events now.
Okay. Or are they? This one is pretty yellowish. Yeah, it's a bit weird, but still, it's orange. Okay. That's nice. So I got the documentation there doing app info. I can
using the whitelisting properties.
Yeah, I can interact with whatever light I want. But what's the point of having 3 lights, really, I guess?
Yeah, we can showcase the partitioning.
So what's partitioning? I guess this is a problem of scaling out, right?
Right.
As if I have a business app that needs to...
Whenever you need content-based routing of your messages, for example, you want your messages to go into a specific app instance. And you scale out your app instances. This is a real world use case where, for example, you are doing some credit card transaction processing and you want to process, like you distribute your apps, you can scale out all the apps, and then you want these messages to go to per ID, per customer ID.
Okay, so what I'm going to do is create 3 instances of the bulb sync.
So you can choose the ID.
Okay.
And you can determine which app should receive the messages.
Okay, based on some criteria, right?
Yeah, that's the content-based routing. So you need to specify partition key expression,
okay,
or a partition key selector criteria to determine where should these go. So in this example, we know we have XYZ coordinates events, right? So let's say if you put the block events in there, and every X axis that you put, those events would go
in the same row, are going to go on the first light bulb.
Right.
And then
the second one would go to the second bulb.
And then it's a modulo operation in a way.
Yeah.
Okay. So how do I do that?
It's the same with the partition criteria. We can have a new stream now.
Okay. So string create again.
Yeah, the same thing.
Baz. So I need to do TCP client.
The same stream definition. The output type text plain, because we need string in our sync.
Okay, and I'm going to put it to
the bulb.
The bulb. I guess
you don't want to deploy it now because these partition criteria need to be applied when we deploy.
Yeah, but how will the bulb app know? So I'm going to create several instances of the bulb app, right?
Right.
But how would each one know that it's instance number 0, instance number 1, instance number 2?
So by default, Spring Cloud Stream provides instance index. So it has to have an instance index property in there.
Okay.
So that's how stream partitioning is working in Spring Cloud Dataflow. So it requires an instance index so that the ID would be determined which app instance it would go in.
So basically what we would like is that index
would be our ID here.
Goes there in that
But this
ID.
is normally not required. You don't have to put in the instance index. But in our case, we require the instance index.
Okay, so we're going to derive the ID from the instance index, maybe add value for that.
Add value.
And use a spell expression, something like that?
Sure.
So the instance index, is it what, 1, 2, 3?
It's a 0, 1, 2.
0, 1, 2, okay.
So here 1, 2, 3, so we need to add one more.
We need to add 1,
yeah.
Okay. So just use spell. This is where it's convenient. And we're going to say 1 plus and the instance index. So it's passed as some configuration properties.
Property in there, yeah.
So environment variable, I guess.
Yeah.
And we're going to say that
have a
by
default value if you want.
We're going to go 0, right?
Sure.
When we have only one instance, this is what we get. Okay. So do that. Rebuild the app.
Build it.
Okay. And then I'm going to create an
app.bulb. That's for the bulb app.
Yeah. And add like a 7th line. XYZ. So I'm currently at, let's say, minus 198. And as I move, this change.
Determine which app instance ID it has to send the message into.
Okay. Before that we add, because maybe they're conflicting with this. Let's try it without and see what happens. So what I'm going to do here is say I want to partition the payload. Is that what you're saying? So I just have to say payload.x maps, or as bin properties. It can understand the X attribute in the JSON.
It's a spell expression, so you have a payload variable available, then you can refer to the data, the field name in there.
Okay. So if I look at what we get there, we have TCP client has been deployed as instance number 0, and I see there is now instance 0, 1, and 2.
Right, so there are 3 apps deployed now.
Okay. So if we go back here, and we try that. So maybe this is, yeah, they're conflicting a bit. So
we could destroy the other streams.
Yes, let's do that.
Because the problem was we already had deployed some other streams. Those are still emitting the events. Those are coming to these two bulbs.
So the last thing is bad, so I'm going to destroy
foo and bar.
So it takes a bit of time so that the app gets the command to be destroyed. If it doesn't, we can help it a bit. Actually, it's a bit complicated to know which one is which. So we'll just wait for it.
Bar.
Yeah. So these tap things that we have, we can leave them right here, right? Mm-hmm. They don't conflict. But everything with the bulb we want to destroy.
Keeping the time in line, like, can we destroy these bulb streams and then recreate? Or like kill those JVMs in there?
We can do that, yeah.
Looks like it's taking some time.
Yeah, it's taking a bit. There is a timeout in the local deployer. If it doesn't respond to the actuator, it's going to be killed. I guess we can wait for it, or we can help them. So we can destroy everything if we want. So you see, these are all the apps that we created.
Demo.
And so yeah, let's kill everything and start over.
Remember, local deployer is only for testing and debugging. And once we are done with this, we can move to a specific deployer of your choice. It could be Cloud Foundry, MISOS, Yarn, or Kubernetes.
Okay, so let me recreate or redeploy that app because it thinks it's not deployed there.
Yeah, so we have the stream definition already. Good.
Yeah.
Can we get the stream list command? Let's see.
Oh, it still thinks it's
yeah.
deployed. So I'm going to pretend it's undeployed. Play it again, and then we can go for it.
So now we know that the foo and bar aren't there.
Hopefully I destroyed them all. So this is the x-axis. Okay. And so if I say green on this one.
Can you choose a different color? It's already green in there.
Yeah, sure. It's not going through. This is the demo effect. Oh, this is so sad.
No, we can debug. Oh, that's why we have the local deployer, Eric. So
why? Oh, why? You know what?
Stream list.
Yeah, let's get rid of all the streams. I'm not sure I killed them all. So let's do that. In the meantime, if you guys have any questions, I guess now would be a good time. Any questions? Can you take the questions?
Yeah,
while
sure.
I do that.
Yeah, that's already available. Oh, the question is in the Spring Initializer page, the Kafka stream dependency, is it available or it's in preparation? We already have it available. You don't see it? Oh, okay. That should be a bug then. Maybe, yeah, we will take care of it.
Yeah, they're ready.
We have been using it, yeah. The Kafka stream and Rabbit are already GA. Yeah, the question is about Stream Listener. Yeah, so Stream Listener is a service activator itself, where you can also have the message conversion comes into place. In this case, we have to have a custom message converter. We don't want to depend on the existing one because the way the TCP client has this data content type already in there as byte octet stream, and there are some issues when you convert octet stream to text line when you do that.
Or to POJO, yeah. So it's because of the way the TCP client emits stuff, it outcodes the content type to be octet stream. And then if we were using the automatic conversion that Spring Cloud Stream provides from, say, this to the state class that I created, that would have been a good idea.
Yeah, that would be the perfect thing with the custom message converter. So you can have, instead of service activator, you can have stream listener with the input channel, and that's going to take care of your message conversion automatically.
So yeah, you would want to put input as the method signature here. The problem, though, is that when you go from byte array to JSON, the default conversion of conversion of byte array to JSON is to base 64 encode the byte array. So this is why it doesn't work. So we cheated a bit, and this is why we put string. What you could do is have a custom transformer that would override the content type, for example. For example, that overrides the content type header that TCP client provides or stuff like that. I actually created an issue for that because I think it is technically correct what is currently happening, but it's a bit weird, right? And it's it precludes you from using that nice conversion.
Stream
so
listener thing.
We're going to think about that and see if we can have an extra parameter that says force this content type or stuff like that.
Yeah, that's the reason we always had this input type and output type defined. Otherwise, you wouldn't have had it in the stream.
Okay, last chance. This is the first bulb. Third bulb.
Can pick green.
Middle bulb. Okay. So if I go back to green, here it's the third bulb for you guys in that row. So as long as I don't leave that row, it doesn't change. If I put it back to magenta, it's still that thing. If I change row, I put there, another one changes color. And if I go there, the third one changes color. So this is partitioning. And it does work.
Basically, what happens is that TCP client receives the events from the block events, and then it knows where to send the messages based on the partition key expression that we defined, which is the X coordinate. And it does the modulo. That's the default. You can have your partition key selector class where you can control how you want to do the partitioning. In this case, it's a mere X coordinate value, as it does the modulo and then sends the app, sends the messages to the resultant value, which is the app instance index.
Okay. I guess we're running out of time. Are there any questions? We are available after the session, obviously, so feel free to ask questions afterwards. This is it. Thank you.
Thank you.
Don't forget to play games.